These are the solutions for the study guide for quiz 24. So let's take a look at our first problem that we're going to end up seeing, and we're trying to find the length of the slide. And so it looks like here's a ladder you climb up and you slide down, so we want to find this length. Well, we see that it forms a right triangle, and so whenever we see this right angle, the side opposite the right angle is going to end up being our hypotenuse. So we're going to take the two legs of the right triangle, so this is one leg and this is the other leg, and we're going to square the legs. And so we're going to do 28 squared plus 21 squared equals the hypotenuse squared. So I'm going to call it h squared. And so when I go ahead and square the 28, that gives me, let's see here, that gives me 784. So 784 is the value of 28 squared. 21 squared is 441, and that equals h squared. So I add these two numbers together, I get 1225 equals h squared. So I take the square root on both sides, and that'll give me just h, because the square root will cancel out the squared symbol, and the square root of 1225, 1225, is 35 feet. So moving on to the next one, it says Sue places her 6-meter-long ladder 2 meters away from the base of the wall. And how far up the wall did the ladder reach? They're asking for this distance right here. And so we don't know that distance, I'll call it x. And so what we've got is a right triangle. If you look at it, if I draw this line right here, there's our right triangle. The side opposite the right angle is our hypotenuse. So this time the hypotenuse is given to us. So we've got two legs that we're going to square and add together. So we have x squared plus 2 squared equals 6 squared. So in this problem I need to subtract the 2 squared from both sides. But before I can subtract, I've got to square first. So x squared is going to end up equaling 36 minus 4. And so when I go ahead and do that work, I get 32. So now I'm going to go ahead and take the square root of both sides. So the square root of 32 is going to be somewhere between 5 and 6. And so taking that square root gives me about 5.7. So it's a little closer to 36 than it is to 25. So 5.7, good approximation for the square root of 32. Moving on to the next problem, it says you are playing capture the football. You are 50 yards north, 20 yards east of your base. The other team's base is 80 yards north and 60 yards east of your base. Okay, so they're comparing it to your base each time. So let's go ahead and set up a coordinate plane here. And we'll say this is your base right here. And so we're going to do the U first. You are 50 yards north and 20 yards east. So this is north, this is east. And those are both positive directions, so I just have the first quadrant here. So 50 yards north, so I'm going to count by tens here. So 5, 10, 15, 20, I'm sorry, 5, 10, let's count by tens, I'm sorry, 10, 20, 30, 40, 50, and we are 20 yards east, so 10, 20. So I'll go ahead and put a dot right there. And then the other team is 80 yards north, so I need to go up 3 more spaces, and 60 yards east. So I'm going to go 60 yards east first. So it's 1, 2, 3, 4, 5, 6. And then 80 yards north. So 1, 2, 3. So I'm going to go ahead and put a dot right there. And so that's the distance I want to find, because they say how far are you from the other team's base. Okay, this is you. This is the other team's base right here. And again, we got those 2 points because they were comparing to your base. And so what we want to do is we want to make a right triangle. And what I'm going to end up doing is counting the spaces going down. So I see that the distance from north, from you and your other team's base is, if we look at the northern directions, 50 yards north and 80 yards north. And so if you could count those spaces or just do that subtraction, 80 minus 50, and that gives us 30. So 30 yards is the distance for this vertical distance. Now the horizontal distance is the easterly direction. So we have 20 yards east and 60 yards east. So if we subtract those, 60 minus 20, that gives us 40. And so those are the 2 legs of the right triangle. We're trying to find the hypotenuse. So we're going to do 30 squared plus 40 squared equals, we'll call it x squared. And so I'll go ahead and square these numbers. This makes 900 and 1600. equals x squared, which makes 2500 when I go ahead and add those two together. Taking the square root will cancel out the squared symbol and leave me with 50. So 50 yards is the distance I am from the other team's base. Taking a look at the next question, it says, is the triangle right? And then that's formed from the tent and the rope that's kind of holding up the tent. And so what we're going to do is, we see the right angle symbols right here. The hypotenuse is the longest side. And so we're going to use the converse of the Pythagorean theorem, which says if we take the two legs that are known and square them together, and then add them together, and we'll set it equal to the hypotenuse, the longest side squared. So just substituting the numbers in the Pythagorean theorem, and when I do this work, I get 2,304 plus, and then 64 squared makes 4,096, 80 squared makes 6,400. So when I add these two numbers together, I surely get the same answer as 80 squared. So 6,400 equals 6,400. So our phrase that we're going to use is this. We'll say the ropes form a right triangle because the side lengths satisfy the converse of the Pythagorean theorem. So moving on to the next problem, it says, how far is the cabin from the peak? So make sure on your problem you read it carefully to see what they're talking about, because I mentioned the base camp here too, but that's not part of the problem. So we're looking at just this distance from cabin to peak. And so what we're going to do is we're going to make a right triangle right here. And so you see how the right angle is right here. We're trying to find the hypotenuse, that distance between the peak and the cabin. So the distance from the base camp to the cabin was 3 units. And the distance from the peak to the cabin is, or base camp to the peak, is 5 units. So we're going to set up the problem as 3 squared plus 5 squared equals, we'll call it x squared. And so we got 9 plus 25 equals x squared. When I add these two numbers together, we get 34 equals x squared. So we're taking the square root. Again, it's going to be really close to 6, maybe about 5.8. is what it rounds to the nearest tenth. And so we're supposed to specify the distance, and 1 unit equals 1 kilometer. So we'll say 5.8 kilometers would be the distance from the cabin to the peak. So now we're trying to simplify these radical expressions. So the key is to look for the perfect squares underneath the radical signs. So I see that 9 times by 11 makes 99. And 9 is a perfect square, so we'll be able to factor that out. And so the square root of 9 is 3, and I still am left with that square root of 11. So my answer is going to be 6 square roots of 11 because we multiplied the two numbers that were outside the radical sign. So the next problem is going to be a little bit more difficult because we'll have a variable term involved in it as well. So the first step is to take out the perfect square. So I look at these digits, and one of the rules is if you add up the digits, 2 plus 4 plus 3, and we'll see what it makes. It makes 9. Well, 9 can go into 9, so I know I can divide this by 9. So I'll do that division, and 9 times by 27 ends up making the 243. Well, 27 breaks down too, so I get another 9 out of that. And so I could have multiplied or divided this by 3 as well, and then I would have gotten 81, and that's a perfect square. So those are numbers underneath the radical sign still. Still have this negative 2 here as well. Now h to the third, anytime you have an odd exponent, you're going to take away one of those h's, and you're going to be left with the closest even exponent, or the one that's a little bit smaller than the one you're given, h to the second. That's going to be a perfect square because all even exponents represent a perfect square. So now we're going to go ahead and take those square roots, the numbers we've got that are perfect. So 9 is 3. The square root of 9 is 3. We've got another 9, so we've got another 3. Can't take the square root of 3, so we're going to leave that one there. H to the second, that makes h when I take its square root. and this h I cannot take the square root of. So you take the two that you cannot take the square root of, and you just write them underneath the radical sign. And you go ahead and multiply the numbers that are outside the radical sign. So we get 6, 3, make 18. So negative 18h times the square root of 3h. So moving on to the next problem, what we'll see is we see a product. So it's the same problem we had here, except we're multiplying another radical by it. Now, what we're going to do that's a little different here is I'm going to look for common factors, because I can rewrite this using the commutative property, the negative 3 and the 2, and then I can write it underneath one big radical sign, 40 times 56, and then I'm going to combine these x's. The reason is because if I do, I get an even exponent, and that's a perfect square. So rather than multiplying these two numbers, I'm going to go ahead and look for a common factor between these. Rather than even just a perfect square, I can look for any factor that's the same. And what I see is 8. You see, 8 goes into both of these numbers, and I picked that number because 8 times 8 makes 64. And I can go ahead and take the square root of 64. So I'll go ahead and show that. I got 64, and then 5 and 7. And then I've got still this x to the 6th. So you see that's all underneath the radical sign. So once you get those two factors that are the same, you can take that square root once you multiply them, and you'll get that factor outside the radical sign now. So now we've got negative 3, 2, and 8 outside the radical sign. Well, the x to the 6th is a perfect square. It makes x to the 3rd. Just divide the exponent by 2, and that's what you get. And I just have the 5 and the 7, which are not perfect squares, underneath the radical sign. So I go ahead and multiply these numbers. And this makes negative 48 x to the 3rd times the square root of 35. Looking at our last one here, we need to rationalize the denominators. So the first step I'm going to do is I'm going to simplify this. And I see 8 has a perfect square in it. 4 is that perfect square. So I'm going to go ahead and simplify this down to the square root of 5 times by 2 square roots of 2x. And so now I'll go ahead and multiply by that factor of 1. And we're going to treat 1 as the square root of 2x over the square root of 2x. I do that to make a perfect square in the denominator, because that's what we want to do. Rationalize. Get rid of any radical sign in the denominator is what that means. So I'm now left with the square root of 10x on top. 2x times 5 makes 10x. Down below, this makes a perfect square. You see, that makes the square root of 4x squared, which just makes 2x. So I just have 2x times by this other 2 that's there. And so I go ahead and multiply these numbers, and I still have that 10x on top underneath the radical sign, and I have 4x down below. Now don't get in the trap of trying to reduce this. You cannot reduce that because the 10x is not really 10x. It's the square root of 10x, and you'd have to take that before you did the division. So that's our answer. So those are the types of problems that you're going to see on this week's test. Good luck.